Okay, so if you think back to derivatives, when we first started talking about derivatives, way back at the beginning of the course, we talked about how their interpretation was that the derivative of a function at a point was the slope of the tangent line. At that point. So we were talking about how it was a slope. Well, now we're going to talk about antiderivatives and the integral. What does that mean? So far we've talked about how you can have an integral of a function dx, and you find the most common, this is equal to big F of x plus c. But what we can actually do are put what are called limits on our integrand. So we might see something like the integral from, we'd say a to b of f of x dx. Okay, and we'll talk about how you actually find that, but what it means is that we're going to draw a picture, draw the graph of f of x, so let's say it's just like this, and a and b are going to be x values. So we'd say from a to b, what this means is this is the area under f of x between x equals a and x equals b. Now when we say under, what we really mean is between f of x and the x-axis. So here what we would do is we would say, okay, the integral from a to b of f of x, we're saying it's the area between a and b under f of x and above the x-axis. Okay, now if you have something where your function goes below the x-axis, okay, so let's say your a was here and your b was here, then this area here will be positive, and then we'll actually subtract the area below, so this will be negative area. And I know that's hard to think of. You've never heard of negative area before, but when we're below the x-axis, we'll consider it negative. So that's the geometric interpretation of the integral.